Joins in SQL. What is inner join, left outer join? Is there any difference? How does it compare to right join or cross join? Should we use it or shouldn't we use it at all? How to combine multiple tables from your relational database. This will be all in today's video. And yes, of course, I know your LLM can write your SQL for you, ChatGPT, Gemini, Claude, whatsoever. So why even bother with recording this video? Well, first of all, every single data channel on YouTube should have a SQL comprehensive video, and this is what we are going to tackle today. So welcome back, friends, and again SQL in today's video, but without any theoretical slides, without any presentation, just pure code and examples and practice. So let's get into this one, and I will walk you through each and every single SQL type of join and how does it work in practice. Let's get into it. Perfect. So we are going to need a couple of tables in order to represent the joins in SQL. First of all, products, product manufactured in region, and employee table that we will later on use for hierarchies. These are all simple tables. As the name suggests, product manufactured in region is just region name, region code, and established in year. So for instance, you have multiple plants where you are producing some manufacturing products, I don't know, your screws, whatsoever, PCs, and you have those plants in multiple regions potentially, right? So we can produce those elements in multiple regions. So we are going to create this table, and as well the products. Products will have a product name, code, quantity, what was the manufacture date, and the relation to manufactured region, added by then created date. What is important and what you might see here is that I don't create explicit foreign key relation with the product manufactured region. There is no ID dependency here whatsoever, but still we are going to use this information to join our tables. Now, what we want to do is to populate those tables. So we are going to populate product manufacturer region with some regions: Europe, APAC, EMEA, North America. And just for the sake of clarity, North America is there to showcase you the join type where you will not get any results because there will be no products assigned to this one. But let's not start with the results. Let's start with some facts. Products. You can see product 1 produced in Europe, product 1 also produced in EMEA region, so a bit different regions in terms of naming. Product 2, 3, and 5, and the 5 is an orphan product from the perspective of region because it has set manufactured region to null. It's kind of important because it will make our life easier when we are going to see the join types in action. In real life, of course, this would be the data quality issue because we might want to have each and every single product in all regions. Otherwise, it might be an issue on our side. So, basic joins. Let's start with the most common one, inner join, which is basically an intersection. In the infamous, from my perspective, Venn diagrams, you are going to see two circles combined with one another, and the representation that is connecting one circle and the other, the intersection of that one, is actually the representation of the inner join. And how we are going to define it? So the base table, in our case products, then the table that we want to join with, product manufacturer region, and the join type, which in our case is inner join. Inner is a specific SQL command that you don't need to provide. So when you will write something like this, it is also referenced as inner join. Same will be for outer when we are going to go to the left and right joins. But I do recommend to keep the inner join just for the sake of clarity and readability of the code. I know this is a couple of characters more, but still, please use those characters unless it's some sort of your scratch pad that will not land into production. And I guess we all know that it will land eventually. But please use it just for the sake of clarity. And then we are joining these two tables, right? Products and product manufacturer region. Based on what? Based on region name from product manufacturer region and manufacturer region from the products table. And we are listing out some of the columns there. So the output here will be basically an information that we have product 1321 and the corresponding manufactured regions. So 4 records. But as you know, we have 5 products. So why the product number 5 was not listed? Because simply there was no relation to the product manufacturer region. We are not able to join null with some value from the region name. Left join, and actually left outer join. This outer is kind of important to emphasize that this is not a relation between two tables, the intersection, but actually it's something that we have a table, an object A, and we are adding to that object, checking to that object with B, right? So basically what it does is it is going to return everything from our base object. So the base object, I mean the from here, and we are going to try to join everything from the product manufacturer region. The result would be that we should see all of the records from the products tables and also the matching informations from the table that we are joining with. So in our case, product manufactured regions. Let's see this one in practice. You see, now we have 5 products, all of the products that we actually added, but for the manufactured region and established year, which is a column from the product manufactured region, we are going to see values only for the 4 products where we do have the relation with. And the relation is based on the same fields as previously. So region name and manufactured region actually, okay? And here, again, same story as with inner join. Inner might be removed and it would also work. In case of left or right outer joins, outer can also be removed and it will produce the same results. I've told you that inner is important from the perspective of code readability, etc. In case of outer joins, left, right, full, I'm not that strict, and yeah, left join is just enough or right join is just enough. So in this case, we might want to remove outer and it would be also okay. Right join, it's basically different, actually the type of left join, but you are going to join with the right table. So our base is not the products table in this case, but our base is product manufactured regions, right? So we want to return every region plus all of the matches from the products table. Now you will see that actually North America will appear because counterintuitively we are not, base of our join is not the products, but actually the base of our join is product manufactured region because it is referenced as the table next to the right join clause. The join key is the same, region name and manufacturer region, and of course the product table is also based on the products. Now, should you use right join even in the production? And the short answer is no, you shouldn't. There is no clear or easy maybe thing where and when you should use right join in production database. It's much more readable, much more concise, and much more strict to just use left joins, or in case of other types of joins like inner joins, rather than going through the right join. Why? Because it brings more complexity and troubles in reading the code. So we are normally, when we are reading the code and we are thinking about how our data are interconnected, related to one another, we are thinking from left to right, right? So our base is, let's say, products tables, and then we want to somehow join another table, be it inner join or left join, and we are going traversing the tree downwards if we have more than one single table that we are joining. When we are introducing right join to already complex query with some from and some other joins, we need to stop for a second and change the perspective that from now on the base of our logic will be the table on the right. So this brings a ton of unnecessary complexity, so let's not do it in the production code. However, you might experience this one in your production code. Why? In majority of the cases, this is because the refactoring of already existing code, where there was a from, most likely with some subquery, then some left joins, inner joins, was too much of a hassle to rewrite than to just simply add the right join clause. And well, unfortunately, if you have such examples, well, it's up to you. I would rewrite it just for the sake of simplicity, but this is the only viable, let's say, case where you might get into the real experiences of adding or having the right join in your code. Normally, feel free to use inner join, left join, and just try to not use right join in your code for the sake of other people and team members in your team. Full outer join. So we had left join, so we have base as our left table and we are joining all of the corresponding records from the table on the right hand side. Then the right join, where our base is right table and all of the corresponding records from left hand side. And now the full join, full outer join. So basically here we are going to return everything from the table A and B. When there is a match, there will be match in terms of the columns, but if there is no matches, then just the records will be seen in the result section, but without information matching from either table A or table B. Let's see this one in practice. When it comes to syntax, it's similar to previous ones. So we have the base table products. We are saying that we want to full join the products table with the product manufactured region based on the same join keys, so region name and manufactured regions. But as you can see now, we are going to see all of the products 1, 3, 2, 1, and 5. The product 5 will not have any region information. However, we are going to see also another record from the regions table. So it's not that we are going to just in the result set only information from the products, so 5 records. No, in case of full join, we are going to see all of the records from table A, all of the records from table B, and if there is a match between those two tables based on the join key, in our case region name and manufacturer region, they will be shown in the result set in the appropriate columns. If there will be no match, then simply we will have nulls, as in case of North America or product 5 here. So these are basically the fundamental join types in SQL. Inner join, left join, right join, don't use it, and full join, okay? What other types of joins we have in SQL and why they are important? Cross join. You might have heard about cross joins, or you might already know the cross joins and you might think that it's plain evil, you don't want to see it in your code. It will make a Cartesian product, so basically everything will be joined with everything else. You don't want to do it. But hold your horses. There is, at least from my experience, one case where you might want to use cross join to help yourself, but use it with extreme caution. So imagine a scenario where you are producing or manufacturing a product, and this product is being manufactured across all of your regions. So you have plants in every country in the world, right? And you are producing that product in every plant. So instead of doing, for instance, left join and do the join key, you can safely say that for this particular product, I want to cross join with my manufacturing region table and see all of the information from that one. How will it look from our perspective? So we have the products table, the base, and we are saying that we want to create a cross join with a table called product manufactured region. And as you can expect, all of the products will be joined with all of the region and vice versa. So product 1 will be in all of the regions from the regions table. Product 2 will be in all of the regions from regions table, 3 and 5 as well, okay? Again, not really recommended on the production code base. There are specific scenarios, as I've mentioned, when you explicitly know that a certain situation will require and will be a business logical to have this information across all of the other informations from particular table. But in general, still, for the sake of readability and clarity of the code, it might be much better to just use left join for this type of exercise. Natural join, just not use it. But what is it in general? So it's basically, it's a type of join where you are not saying based on what columns you want to join, and you are leaving this for your database management system to deal with. And how does it deal with it? It checks for the same column names across two tables that you are joining, and based off the same names of the products tables, it will create you a join condition, right? So basically inner join condition. In case of our example, we have products and product manufactured regions, and it will check all of the columns in the product tables, all of the columns in the product manufactured region, and for those that matches, the column names that matches, it will create a join condition. So in case of our result set, you will see that we only have 4 products, and the join was based on manufactured region information. Other type of joins. So you might have heard about semi-join or equi-join or non-equi-join. So let's get into this one. So what is actually a semi-join? This is a type of join where we do have a base table, like the products manufactured region, but we are actually checking the existence of an information in another table. So we are actually using where exists syntax in order to check the existence of that specific informations. When we are going to use it, for instance, when we just want to have an information if a certain product is manufactured in a certain region, or what regions have at least one product. Okay, so this is type of join to use it in that case. It's named semi-join, but actually the reason is quite simple. So product manufactured regions, so we are going to get all of the regions from the regions table, and then we are doing a exists syntax where we are actually just checking. So where exists, we are not returning anything from products table, we are just checking if a particular region has a product matching. If it has, it is being returned here as in the result set. Okay, now anti-join. So anti-join is basically where plus is null, where left join plus where is null. So example of this one, when we want to just showcase which regions does not have any products matching. So we are going with the, again, product manufactured region as base. So we want to list all of the regions that doesn't have any matching products. And then we are just doing a left join, products P, same join condition, manufacturing region name, but we are adding a filter where PID is null. North America should appear here, and it's there. How to do it differently? You can do, again, semi-join, but with where not exists. And this would give you the same result. Equi-join, any type of join, be it inner join, left join, right join, full join, whatsoever, where our join condition is based on the equality sign, this one, is called equi-join. So even though we have here a left join, because of the fact that we have here an equal sign, we are going to say that this is an equi-join, left equi-join, right? So because we are having manufactured region equals region name. How to make non-equi-join? If you are going to replace equality sign in your join key with any other different type of sign, like greater than, lower than, different than, you are going to get a non-equi join type. And what is also important to probably emphasize here is that our join conditions are not only related to columns. You might add here like a case, for instance, case when something equals something else, okay? It's also possible, but we here need to keep in mind the performance impact of such operations. Joining based on column names most likely will use indexes if you have them in place. So this will be much faster than some complex operations with complex formulas inside of this particular join conditions. Now, self-join. Self-join is probably the biggest example for self-join is hierarchies in companies. So we are going to create a new table called employee. An employee has an ID, it has a first name, last name, and also has a manager ID. What is this manager ID? This is basically a relation to nothing other than employee ID, and in case of null, no reference to employee ID, it means that this is the boss. This is the biggest person in the company, CEO, or however you want to call it. And let's add some informations there. So we are adding 4 records. And we have added Krzysztof, Ania, Tomek, and Jessica. And as you can see, Krzysztof does not have any manager, so he is the boss. Ania is reporting directly to Krzysztof, Tomek is reporting directly to Krzysztof, and Jessica is reporting to Ania. Okay, and as you can see, when we are doing this from employee, and now you can use whatever type of join you want, left join, inner join, but you are joining to the same table, employee to employee, using a join key employee ID equals manager ID. You will see that the employee name is Jessica, but her manager is actually Ania. And we are traversing this through the whole structure. Let's park here for 1 second. What is happening when the hierarchy is much more complex, much more nested? So we have not just one level, not just one level of hierarchy, but more levels. So in that case, first thing that will maybe come to your mind is that, oh, we are just going to create more left joins here, right? So we are going to do the left join, and from employee M we are create N, let's say, and here we will do something like this, and that would be okay. So we have level, for instance, level 1, and this will be level 2. Okay, so we are going to get to the lowest level. Okay, fair enough. But if we don't know how many levels deep is our structure, or it's like maybe not 2 joins, 2 levels, but 30 or 20, are we going to create 20 left joins? Probably not the brightest idea. Some, not all, but majority right now, and this will change in the future for the better. Some relational database management systems have this functionality that is called recursive CTE. So common table expression that is recursive. So this is not part of this actually video, but in general concept is that we are defining the base. So who is the manager? Then we are creating a union with these managers based on the keys. And the recursive CTE responsibility is to get to from the top, from the managers, to the lowest hierarchy possible. So it's basically doing you like a for loop inside of the SQL. Not all of the DBMSs supports that one, so please check yours for the support of it. Postgres, for instance, does it, and it's working like a charm, not only for the hierarchies, but in general the concept here is that it will be most useful in terms of hierarchies. Lateral join. Now, that's something nice. Imagine that you want to have a for each loop inside of SQL. How to do it? So again, this is not supported by all of the DB database management systems. Postgres supports it, for instance, and when it is extremely useful. So imagine a scenario where you just want for a particular region, right, where we are manufacturing the products, you want to get a product with that was manufactured the earliest, or that was most recently manufactured. Okay, how you would need to do it, because you are not allowed to just simply left join and do limit here, just limit 1 in the join clause, because you will be left with just one single record. But you want to actually do for each region from product manufactured region, join with products table, and based on this join, get me just one single element based on the join condition between one record and another, get me one single element as the result set. It's extremely useful in cases when we, again, just need a handful of information, especially like one single record to correspondence of the particular table. And by design, SQL databases are not allowing you that one in terms of just simple left or right or inner joins. But with the use of lateral, here we are basically doing a for each loop. So we can imagine that each and every single record from product manufacturer region will be checked against the subselect inside of the left join formula. This correlation that we are doing here, this join condition, manufactured region from products table and region name, normally without lateral join will not be possible here to obtain inside of subquery. So how does it work exactly? We are going to get 4 regions. North America would be obviously empty because it doesn't have any relation to the products table, but all of the rest product 1, 3, and 5 would be obviously present here with appropriate manufactured date. Now, some pitfalls, what to watch out for. Where versus on, that's the most common mistake, okay? So imagine where we have a situation where we want to join products table with the product manufactured region, okay? The join key is the same as previously, region name and manufactured region, but we are adding here a join condition and established year is 2012. Why we are doing that one? Well, we just want all products alongside with the information if they are from 2012, right? So this is our base. What should be the output? So basically the output should be that we are going to get all of the products, and if they were actually when the manufacturing region was actually established in 2012, there should be this information present in established year. So this was our base. As you can see, we are getting all of the products, which is something that we wanted to have. And in our case, there is no information about established year because apparently when it comes to our data, 2012 is only for North America, but we don't have it in we don't have this 2012 in the data. If we would switch to, for instance, 2019 here, you are going to see that the product 2 and product 3 will actually have a match with this established year. This is the correct approach. What is an incorrect approach? An incorrect approach is that instead of keeping that in a join, we are actually doing that in a filter. And how does it differ? So when you are doing a join and adding a join condition, you will still get all of the informations from a product, from the base table, so from the products table. Then the join condition is being applied. So we are joining with a table B, in our case product manufactured region, based on the join condition, okay? But when using a where, you are going to filter out all of the records. So instead of seeing all of the products, in our case, you will see nothing, right? So there are no products that were established in a year 2012, but actually we want to see all of the products. And if there is like established year not present, then it simply means that it wasn't established in 2012. And we might want to create a Boolean flag just for this one, but not filter them out completely, right? Because we might need these records further down the stream. And the second most common pitfall, I'm not saying that we should avoid ORs in join conditions. It depends on the actual case. It depends on our table sizes, statistics, indexes, etc. But in general, for the larger databases, larger data sets, when we are joining two tables, products and product manufactured region in this case, and we are joining based on region name and manufactured region and region code and product code, which obviously is a wrong join concept, but just for the sake of this exercise, you are going to end up with nested loop join usually, right? Because first what needs to happen is that first join condition needs to be checked. Okay, so this is, for instance, this region matches, this doesn't, this matches, this doesn't. So we are going to get a list of true and false, and then OR needs to be executed because this is not an AND. So this and this needs to be fulfilled in order to get you the results. But in our case, it will be that this or this will need to happen. What would be the better approach? Either split it to separate queries, depend on your use case, right? Whatever you plan to do. Either split it to separate queries or make a common table expressions with some filters and then do, for instance, unions, right? So for one base might be this join is just for the products matching on region name. And this list is based on the products matching on region code. This kind of operations would be executed separately and just union together as a two separate result sets. So please keep this one in mind. I'm not saying you shouldn't do it, I'm just saying that you should take a look at the performance perspective. So just to sum it all up, couple of fundamentals in terms of joins: inner, left, right, full joins are the basis. You shouldn't use right in production. That's it. Just keep that in mind. Just use left, inner, full, depends on your use case. Outer and inner clauses in SQL syntax are optional. You don't need to use them, but for the sake of clarity and visibility, please just use at least inner to just let your developers, friends, colleagues from your work know that you actually wanted to do the inner join here. Next, the, let's say, exotic naming like equi join, non-equi join, semi-join, whatsoever. It's nice to know them, that they are named like this one, but don't get me wrong, if you will not communicate with your audience that right now you are doing an equi join or right now you are doing a non-equi join, nobody will blame you. The most important factor is the business logic that you've implemented behind the scenes, and that it is correct, not that you've managed to implement a non-equi join based on some sort of join condition. And the last but not least, when it comes to hierarchies, you have the join type that is basically a self join, but in terms of more nested structures, please consider checking recursive CT in your database management systems for this one. And always think about what you want to get from the joins, whether you want to get all of the records or filtered out the records. In that way, you are specifying the queries totally differently. Keep in mind the performance. You can always check the performance with Explain Analyze. More about this one in upcoming video. That's it. I hope that it was clear, concise, and crisp, and I promise you that one, I will not create any more videos with just the base for the SQL joins. It needs to happen, it needs to be in this channel, but that's whatever will be for the base of joins. We are going to talk more about algorithms of joins, so hash join, merge, nested loops, etc. We are going to go through them. These are actually internals, and these are important. But here, the base joins, I'm done. If you have any questions, please feel free to reach out. Thank you for today. Thank you for your time. Thank you for watching. Bye-bye.